Hello everyone, this is Narjis Zahra, my partner Mursaleen, and I have worked on parallel path magnetic technology as a part of our machines research project. This is a new research that works to increase the efficiency of the device. Joe Flynn has been working for the past 25 years on PPMT, which works on the principles of steering or redirecting the flux of the permanent magnet. This we can see is a very basic device, is a very basic PPMT device. We'll start with the very primitive concept of PPMT. We see that if no current passes through these coils, we have induced for 1 unit of induced force here and 1 unit of induced force here on, and this is the ferromagnetic core that we have. However, when the current starts flowing into the coils, they produce their own magnetic flux, which is much weaker in strength as compared to that of the permanent magnets in the circuit. We see that one coil demagnetizes the core, whereas the other magnetizes it. The required input to switch the flux is halved. Consequently, the efficiency of the device is doubled. This is the squared force law in its most essential form. We see that it generates 4 units of force on one side and 0 units on the other. Once the flux has switched and the actuation elements have moved to create an air gap on the zero force side, the steering coil can be turned off and the actuator or the motor would remain in this new state with no power required. A momentary coil pulse with the opposite polarity will switch the actuator in the opposite direction. That is, the 4 units of force will now be applied on the side. This ability to arbitrarily move or steer the force from one leg to the other is the basis of Flynn magnetic art. Simultaneously, we now have a magnetism to engineer a time-varying magnetic field, but by accurately pulsating the field coils, that is, by accurately controlling the flow of the current into the field coils. However, at this point, it should be noticed that the magnetization curve of the core remains the same regardless of the flux steering mechanism, this limits the output of the device. Therefore, the efficiency of the device is doubled, but the absolute output of the device may not be significantly improved. The following video presents a basic demonstration of the said description. We see on one side it's very hard to remove, the magnetic force is very high, whereas on the other side it's barely impacting the magnet. We now briefly discuss the working of a PPMT motor. The rotor of a PPMT motor is similar to that of a conventional variable reluctance motor, that is a rotor without magnets or coils, simply a high permeability laminated iron as shown. However, the coils are wound around each stator pole, and the flux generated by the current flowing in this coil is used to generate torque. In the PPMT motor, the permanent magnet flux plus the induced flux from the load current add to generate the shaft torque. Torque is optimized by proper timing in the switching of the stator coils. The flux of the permanent magnet in the machine is steered by the coils in the direction of the proper poles at the proper times to produce torque. The required input power is much less than that of a conventional motor because of the supplemental power due to permanent magnet flux. Thus, less input power per pound of torque generated. Therefore, it increases the efficiency of a PPMT motor immensely. This flux steering mechanism can be clearly seen in the following simulation. Conclusively, a mechanism to increase the efficiency of a device is created. Thank you.